Writing linear equations. So a little reminder of the two equations that will be the most helpful. There is y equals mx plus b, where m is the slope and b is the y-intercept. And there is the point slope form, where m is the slope and x sub 1 and y sub 1 are the point that you know is on the line. So depending on what we come across will depend on which of those two equations is easiest to use. So what we're going to be working with is a table of values. So there was some equation that I had and I got this set of table of values. So a little reminder about the slope. The slope is the change in y over the change in x. When we had two specific points, we used y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Very similar idea, but we're going to be using it on a table. So the change in y, I'm going to figure out how do you get from -5 to -1. So to go from -5 to -1 means I added 4. I'm going to do this for the rest of this table also. So from -1 to 1, we added 2, and from 1 to 5, we added 4. Now I'm going to look on the other side and find the change in x. So to get from -3 to -1, you add 2. To get from -1 to 0, you add 1. And to get from 0 to 2, you add 2. So if my slope is the change in y over the change in x, the first set of information is a +4 over a +2. And 4 over 2 is 2. If I look at the rest of them, 2 over 1 is also 2. And 4 over 2 ends up being the same problem. So no matter which level of changes you use, your slope is going to be the same. Now a very important part of this table is this point right here. This is the y-intercept, because remember at the y-intercept, x equals 0. So I now have my b, which is a 1, and I have my m, which is a 2, which means my equation is y equals 2x plus 1. So I got my slope from doing the change in the table, and I got my y-intercept from this point existing on the table. Let's try another one. So here's our next problem. First thing I'm going to do is the change in y and the change in x. So for the change in y, to get from -15 to -5, I'm going to add 10. To get from -5 to -3, I'm going to add 2. And to get from -3 to 1, I'm going to add 4. On the change in x, to get from -18 to -3, I'm going to add 15. To get from -3 to 0, I'm going to add 3. And to get from 0 to 6, I'm going to add 6. Now, no matter which of those changes you take, whether you refer to the slope as your 10 over 15, your 2 over 3, or your 4 over 6, all of those fractions are equivalent. Every single one of those fractions reduces to the same thing, which is 2/3. So there's my slope, 2/3. And if we look at our table again, there's our y-intercept. It crosses the y-axis at -3. X is 0, y is -3. So my equation is y equals 2/3 x minus 3. Okay, one more problem with the table. So here's my table of values. I'm going to do the change in y. So to get from 7 to 5, you subtract 2. To get from 5 to 3, you subtract 2. And to get from 3 to 0, you subtract 3. On the change of x side, to get from -3 to -6, you add 6. To get from -3 to 3, you add 6. And to get from 3 to 12, you add 9. So our slope is going to be -2 over 6, or also known as -3 over 9. Either way, your slope reduces to a -1/3. So it's important to have, if it's adding or subtracting, that's why I always put the sign, so that you can figure out if your slope ends up being a positive or negative slope. Now I'm going to look for the y-intercept, and I don't have one. Okay, so this is where just using y equals mx plus b is not going to help us. This right here is an x-intercept, not a y-intercept, because at the x-intercept, y is 0, so that's not really helpful. However, I do have my other type of equation. So this equation here is going to help us. I already have m. I know that m is -1/3, so I can start off with a -1/3. And now all I have to do is choose one of the points. It does not matter which one you choose. So I'm going to choose -3, 5. Minus a -3, because that's my x value, and then plus a 5. Minus a negative is plus. Now I'm going to distribute, because I do want to simplify this. -1/3 x. A third of 3 is 1, and that's a -1, plus 5. And if I combine like terms, I get y equals a -1/3 x plus 4. And there's my equation based on that table of values. Now, if you come across a table of values where you're doing your slopes and you come up with your fractions and your fractions are not equal, there's two options. First, double check your math. And second, if your slopes aren't the same, it's not linear. It's not a line. So you might come across one of those. It doesn't always have to be a line just because it's a table of values. And one little quick reminder, you will be given a graph and asked for the equation. You have done this before. The y equals mx plus b is going to be the most helpful. So this particular line, it has no points, so I'm going to add some. So my y-intercept is going to be a 1. So I already have that part. And for my slope, if I find a nice other easy point, I'm going to choose this one. That means my line's going down 1 over 3, so it's a -1/3 x plus 1.